Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Scott Cain.
Thank you, William. And hello, everyone. And thank you for spending a few minutes of your time on today's Tech to Tech with Kaizen. So, today we're going to be doing a case study. We're going to be talking about finding a well balanced chemistry for PMICs cleaning. Just so we're all on the same page, PMICs are power management integrated circuits. We're going to be using that acronym a few times just so we know what we're talking about. I'm going to be the one presenting this, but I put this together with my colleague Jason Chan. And so between the two of us, depending on where you are in this world, we can answer your questions about this application or anything else in the advanced packaging cleaning styles. So what we're going to be talking about today is really partnering with a flux supplier to optimize the application. So here's the situation. We had a leading supplier of soldering materials for some of these PMIC applications. They had formulated a new material to optimize the customer's application. But what they found out, and this new material was designed to work in the high lead applications utilized by the manufacturing of these parts. But what happened was, with these higher temperatures were implemented, byproducts such as solder spattering and burnt flux residues existed. And that was not going to be acceptable by the end customer as they were trying to build up these PMICs. So the requirements from the OSATs, the CMs within the advanced packaging marketplace, the manufacturing this product, they need to have a low void rate of under 10%, under the power dies, and a decreased solder spattering defect under the higher temperatures. And they prefer to run these at a higher peak temperature, around the 420 to 450 range. And the original material created some solder splattering and the burnt flux residue. So, due to these requirements, the flux supplier created a new flux for applications such as this. Customer had a demand, the flux supplier went to their scientific team, came up with a new solution, and presented that to the customer. And that worked well. The problem was they weren't able to clean it. They sent this material to us. They're like, hey, how is the cleaning on this? We utilized some existing materials from our portfolio of product, and the results were just not acceptable by any company standard. You can see below, this is before cleaning and after cleaning with what was an existing product for Kaizen, and it just didn't really meet the requirements or the demands or the expectations of both Kaizen, the end customer, and the flux supplier. So then what did Kaizen do at that point? We've looked at our current book of materials. None of those are working. We still want to work with this flux supplier. We know we want to have a solution for these PMIC applications. So that's when we bring our team in, our chemist, our scientist, and they start to evaluate what we can come up with as a solution. What we needed to make sure, the main areas of concern that our team needed to evaluate from was the burnt flux residue. We've got to worry about that. With these increased temperatures, there's an increased risk of polymerization as well as burnt flux. That's going to make this process tougher. The second thing is the speed of the cleaning. The customer's requirements was under 10 minutes in the ultrasonics to keep up with their production demands. And the final thing was the metal compatibility. We need to make sure the frames are okay because we can't have the material be too aggressive, attacking the lead alloys or the aluminum or copper surfaces. So our team had three main points that they needed to make sure that they hit if we're going to introduce a new product into the environment for these PMIC applications. So what was the Kaizen solution? Our team tried a number of different solutions. Little of this, mix a little of that, try it out in the lab. That's not it, but it helps us dial in to get the right solution. So at that point, after some time, we came up with the MICRONOX HEXP89, and that met the requirements of this company. This semi-aqueous, well-balanced material is effective on the high lead flux residues and leaves an ideal surface for conditions for post-wire bond and a potting process. It's also effective at the lower temperatures in immersion ultrasonic systems. So as you can see, here are the parameters in the process flow that we did. You can see the wash time is at that 10 minutes. With the 50 degrees C, this product is ran at 100% concentration. We also played with the ultrasonics and tried different kilohertz applications on that. Came up with 40 being the right answer for that. And then you can see the rinsing and the drying to make sure that the product is not only the chemistry does its job in removing the flux, but it also rinses away and creates a clean surface, and we're able to dry. So let's take a look. These are the results of the trial. You can see what everything looked like before and after. You can see that the parts are clean, the flux is removed, you got a really nice solder joint there, everything looks beautiful. There's no effect on the copper or the lead in this application. So the results and the conclusions on this, kind of what happened. Leading flux supplier came to us and said, hey, we're working with these PMIC applications. We have to do a flux with a higher temperature. We're going to need a solution for that. The existing book of KYZEN products did not work for that. That's when the technology and the education of our lab people and their knowledge came into play, created a new solution that works really well in this application, and it's going to continue to be trialed out there in the field, and then will be a new product for us for these applications. So what this really proves is, even if when you're looking at our existing book of product and you don't see a product that works for the application that you're looking for, that doesn't mean that we can't come up with it. We have a team of engineers and chemists that can come up with this for each individual application. So just a couple of other things. Hey, we're here to help both the chemistry suppliers, the flux companies, the machine manufacturers. We're all experts on this. We know these processes. We work together, the three, the chemistry, the machine, the flux companies. We work together and we can assist in all those. You guys don't have to do all the engineering for this. Let us help you out. You have a lot of things on your plate. We'll be happy to assist, take some of that engineering pressure off on the cleaning, provide reports, provide lab results, and then let you be a step ahead instead of taking all that time. And hey, by the way, we love talking about this stuff. So if you ever want to reach out and talk about it, we're always here for that. So in the past, we've done these and had a few frequently asked questions. So just talk about that real quick. With the frame being 10 minutes in the ultrasonic, is that the quickest it could be cleaned? And that's something we really don't know. For this application, we know that the customer wanted a 10-minute process time. So that's really what we focused on, to make sure that we could hit it at that. A lot of times when we run stuff in the lab, it may be for a little bit longer than the final product ends up at. The goal is to get it clean, and then let's work to dial in the application. And so with something like this, we knew what the dialed in number was, so we focused on making sure we got it there. Second is, it was stated that this is still a trial material. What are the next steps until this becomes a mass-produced product? What we do is we trial it in the lab a number of times, make sure that it's going to get the results we like. Then we'll provide that to the flux supplier, let them play with it, and see if it hits their requirements. And then at that point, we'll look for a beta site or two out into the field, trial that, have our local sales engineer in there, kind of working with them, dialing the process, seeing what happens with the concentration and how that holds, what the cleaning is, how fast it loads, etc., to make sure that's the product that we want to produce. And what's the goal of the cleaning besides a visually clean sample? Visually clean is the first part, not only looking at it with your bare eye, also looking at it under a microscope. And then we start looking at the surface conditions. We want to make sure those surface conditions are really good for post, wire bond, and some of the potting processes that the customer will do. So there's a number of steps that go into it, not just looking at it and saying, oh, that looks pretty, and calling it good. Thank you, everyone, for your time today. Look forward to speaking to you on this topic. And now I'd like to turn it back over to William.
Thank you, Scott. And thank you guys for tuning in to this Tech session. If you would like to discuss this topic further or have any questions that were not answered during the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.